All right, let's do it. So guys, let me know if you can't see this screen very well as we go ahead. But hope you're all in the right place. This is astronomy. Anybody not here for astronomy? All right. Cool. Well, I hope you will all stay and be part of this class. I'm going to sort of try to talk you out of staying and taking this class because I want to make sure you actually want to be here. It's going to be a really miserable class if you don't like the kind of class that this is. So I'm going to spend a little bit of time kind of showing you what we're going to do here. How many of you guys signed up for the lab that accompanies this class? Cool. All right, so that's great. The lab's really, really excellent for a companion to what we're doing here. It's essentially a virtual observatory, and that's cool because we don't have a real observatory here. And looking at the stars is important to understanding pretty much everything we're talking about. Now, what's a little bit annoying, but I think will work out for you, is that this class was supposed to be part of the capacities program this year. Do you guys know what the capacities stuff is all about? It's like a GE requirement. So you're required to take some sort of science course while you're here. I guess they call them inquiry and analysis. This course, if you take it with the lab, will count for that. You need to talk to your advisor to make sure that you get credit for it. But you do have to take both of them at the same time. And going forward, so next semester, if you stick around and do the cosmology section of this course, it will be reformatted. But right now, it's listed not as a capacities course. That's a terrible blunder by somebody other than myself. So I apologize on behalf of everyone here. Questions about that? Okay. So the way that this course essentially works is that I stand here and talk for about an hour and 20 minutes twice a week. If that sounds miserable to you, don't take this class. There's, when we do these evaluations at the end, sometimes I get this thing like, I wish I didn't have to sit there and listen to this guy talk. That's what we do here. I'm sorry, that's the course. That's the course that I was hired to teach, so that's what we do. So if you don't want to sit here and listen to stories for an hour and 20 minutes twice a week, I think it's an hour and 20 minutes, yeah, then take something else. Don't waste your time. Life's too short. But if you think that listening to stories could be fun, and you think that the lab could be fun with the virtual observatory, then hang around. So what I'm going to do today is, let's see, I actually made some slides for this, but the basic idea is to orient you to how the class goes, how you're going to be graded, which is important to everybody, what kind of stuff you're going to learn, and how we're going to get there. So, this class is a science class, but it's also kind of half humanities, right? So there's a little bit of math in some of the assignments, but it's nothing to be scared of. It's very entry-level high school math, basic algebra stuff. In general, this class is going to be an examination of how science is this evolving art form and how the stories that we tell ourselves in science are constantly being updated. And I think that if you come away from this with anything at the end of the course, you're going to have a sense that what we're doing in science is we're looking out at the universe, particularly in astronomy, we're looking out at the sky, and we have a little bit of information that comes back. The funny thing about astronomy as a science that's very different from all the other sciences is that you can't stick the stars in a test tube. You can't do nice controlled experiments. So all we have is observations, and the only observations we have are light. So think about that for a second. All we have are some little pinpricks of light in the sky, and we have to reconstruct a story of basically everything. So as you can imagine, that story is woefully incomplete, and it's constantly being updated. So the story that I'm going to present to you this semester is different than the one that I presented last semester, because of all the sciences that I can see, this one's changing the fastest. Maybe computer science, if you can consider it a science, is changing really fast too with all this AI business. But astronomy, planetary science, it's completely on the move right now. All of our stories, all of these theories are totally being rearranged continually. 10 years ago, we didn't have any picture of other solar systems besides our own. Think about that. That's freaking crazy. We were telling a story of how our solar system was formed based only on our solar system, right? It's like if you were studying, I don't know, bacteria, and you only had one bacteria to study, and you were trying to talk about all bacteria everywhere, right? What kind of story are you going to come up with? Well, you probably know a lot about that bacteria. But what can you say about all of them, which is not much. And so that's really cool and really exciting, because the last 10 years have been insane for planetary science. The stories of the planet formations are constantly on the move. The story of this rock we're standing on is completely changing right now. And so a big part of this class and how you're going to be evaluated is thinking about that in the context of what comes next. So there's no exams in this class. Yay. You're going to have a project, a pretty serious, I hope you'll take it seriously anyways, but what that project's going to ask you to do is to think about theories as possibilities for how we might explain something. And so what we have right now in astronomy, particularly this first semester focuses mainly on the planets, the solar system. Next semester we'll talk about how stars work, at least how we think they work. And a bit about all of your favorite exotic stuff, dark matter and black holes and all that, what's going on. That's next semester. This semester is planets. And so for your project this semester, what you're going to be doing is you're going to be actually trying to come up with your own idea as an alternative for some body in the solar system. A moon, an asteroid, a planet, whatever. And you're going to try to tell you're going to do an examination about everything we know about that, and you're going to try to tell a slightly different story for how you think it came to be, which is crazy, but don't worry, that will make more sense as we go along. So, no exams, big project. Now you're going to have these tiny little projects every week to kind of get you comfortable with this. You're going to record that, by the way, on video. So, how you're going to be evaluated. There's going to be a tiny little quiz every week. It should take you 15 minutes. It's over the reading assignment. I'm just doing that remotely, in part because I inherited this course from somebody else, but I think it's a good way just to make sure that you read everything and I don't have to waste time with it in class. The other reason is because I'm not going to be talking that much about what's in the textbook here. So this is part of your incentive for even coming to class and experiencing this is what I'm going to try to do is unpack what people are studying right now about some given topic and all the possible loose ends and ways that that information could be going. So the textbook might tell you something about the origins of our planet, right? The planet was created 4.5 billion years ago, blah, 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 blah. Well, it turns out there's a lot of astronomers that are starting to think otherwise. And so there's other theories and papers that are coming out this year. And I'm going to take the class time to talk about that stuff. It's not in the textbook. So little quiz every week over the textbook. It's not a big deal. Likewise, if you do the workshop, it seems most of you are doing the workshop, there will be a little quiz that goes along with that. That's the entirety of your grade for the workshop, and I believe it's pass-fail. So just do it, and you'll essentially succeed. Likewise, with almost every assignment in this class, if you do it and actually put your back into it, you'll get an A in this class for sure. So just do the work. Don't let it go. So another part of the class is attendance. So you need to be here because, like I said, what I'm going to do here has nothing to do with what's in the textbook. Not nothing to do with it, but it's going to diverge from that significantly. So I need you guys to be here. And it would be really, really a lot more fun for me if you were constantly raising your hands and asking questions and interacting with me. Because it's kind of a drag to stand here and just talk to a bunch of blank faces. So, there's usually 1 or 2 kids in every class that like to talk a lot. That's great. I hope there are 1 or 2 of you in this class because it's going to be really rough otherwise. But I want everybody to talk. And what I'm going to do, so attendance is actually worth, I think, 15, it's in the syllabus, I think 15% of your grade. The way that I'm going to evaluate that is I'm going to just have a spreadsheet with everybody's names on it. I know this is rough for those of you that are very shy, but it'll be good for you in the end. At the beginning of the class, I'm just going to take maybe 10 minutes, and I'm going to just randomly call on somebody. And I'm going to be like, hey, Joe, what was interesting about the last class to you? And it'll hopefully start a nice discussion, and other people will chime in. And I'll mark down, and I'll get through maybe a third, or I'll get through like 5 or 10 people each class, and I'll just start over at the end. If you're not here and I call your name, you're going to get a 0 for that day. So if you do get sick, it happens, right? First of all, I hope you feel better. Don't email me and tell me you're sick. I can't do anything about it. What you can do is I'm recording all these lectures. I'm going to put them on a YouTube channel, and I will make a link to that in the syllabus. I think the old years is in there right now, but once we have some lectures, I'll put them up there. Watch the lecture. Send me a short little response about something that piqued your interest, something interesting. Excuse me. And send that to me, and I'll give you credit for being there that day in case I called your name. Questions? 15% of your grade. So come to class. Plan on coming to class. I'm really excited because every time I've taught this before, it's been at 8 in the morning. I live in Grants Pass, so that was really miserable for me. And I think for most students, getting up early in the morning is quite miserable. So there's no reason you can't be here. It's 3:30 in the afternoon. I know you don't have anything better to do. Well, maybe you do, but then don't take this class. Okay. All right. I think that essentially covers how you're going to be evaluated. Anybody have questions? Anybody have thoughts already? Talk to me. All right, so today, assuming that, we'll see how far we get into all this, but I'm going to talk about, I'm going to introduce myself a little bit. We're going to start talking about what the heck is astronomy, first of all. It's not astrology. Somebody already emailed me this morning and said, I'm signed up for your astrology class. I was like, I don't think you are, actually. That's not my class. So, but that's okay. Astrology, astronomy, they sound really similar, completely different ideas. So what's up with that? Science as a whole, like I said, this is basically going to be an examination from a philosophical standpoint of what science really means, right? What does it mean to trust science? Like, what the heck is that? Is there just some big, is there some voice that has all the answers that we can bow down to? It's not that simple. Math, how does math fit into science? What's the difference between math and science? These are things we need to play with today in order to go forward. Physical laws fit into that. We'll talk about them briefly. These are kind of like the road signs for how we're going to navigate the rest of the course. And I'll see if I can make it through most of this today. And then at the end, if there's time, I'll take you on a very quick tour of the entire universe as far as we know it. By the way, here's a good question. What the heck is the universe to an astronomer? Anybody? Take a guess. Yes?
Endless.
What's your name, by the way? Nolan. What'd you say?
Endless.
Endless. The universe is boundless, he says. How would you define the universe, though? Any idea?
Spacious.
What does it mean to say the universe? What is it?
Oh, entirety.
Everything, maybe, right? Anybody else?
A collection of celestial bodies like close to each other.
A collection of celestial bodies. That's interesting. I like that. Anybody else? I mean, this is what's really crazy. So if I'm just talking about the universe and I'm like, there's nothing in the universe, blah, 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 it means a very different thing than for astronomers, because when astronomers say the universe, what they mean is everything we can see. Okay. And in some sense, the universe, the picture we have of the universe is woefully incomplete because we can't see a lot of stuff and things don't totally make sense. More on that next semester if you want to hang around. We talk about all this dark stuff, why we got all this dark business going on. But for astronomers, it's literally what we can see. That's what we mean by the universe. So when I say I'm going to take you on a tour of the universe, I'm just going to take you on a brief tour of what we can see. Okay, so let's see if we can get there. Let's see here. I told you guys how you're going to be graded. Oh, one more thing I forgot to mention. If your grade is stinking for whatever reason, there's no reason for it to be stinking. Say maybe you missed some classes or you bombed some quizzes. By the way, you can do the quizzes as many times as you want, so there's no reason for you to bomb them. You get a bad grade, do it again, okay? Literally, there's no reason for everyone here not to get an A in this class. For some reason, not everyone gets an A. I don't know why. It makes no sense to me. So, it's on you. Okay. You have the opportunity, if you do see your grade starting to plummet, to do an optional creativity project at the end of the semester. You can start thinking about these in advance. This is completely open-ended. I've had people make time-lapse photography of the sky. I've had people write short stories, a book of poems, paintings. I've had someone bake cupcakes in the shape of all the different constellations. I've had everything you can imagine done before. And usually people get a real kick out of this. So you have until the end of the semester when the final project is due to get that done. So keep that in mind too if you do it unless you don't need to, or just do it for fun. Okay, who am I? So look, I am not a professional astronomer, which I know is heartbreaking, but if I was, I probably wouldn't be at Southern Oregon University because we don't have an observatory. That would make zero sense, okay? My background, my PhD, I actually did it at Columbia University, which is in New York, and it was in elastic mechanics of molecules, right? Which might seem a little weird because why is this guy who's doing molecular elasticity teaching me about astronomy? Here's the thing, folks. So I liked that definition somebody said. What was your name? Caleb said about bodies and their relationship to one another. Well, here's the thing, folks. Everything that we can see in the sky is not only a body of some sort, and we'll talk about that word because it's really important. They're all made out of atoms, too, okay? So atoms, this really old idea that actually some Greek dudes came up with thousands of years ago, which is just this idea that there should be some reducible component in the physical space from which everything else is made of. And we kind of readopted that idea in the last 100 years and took it quite seriously. It's gotten a bit more complicated because we know atoms can be broken apart, so atoms aren't the fundamental unit of matter. But the point is that atoms are going to explain everything that we talk about in this class. Well, they're going to explain half of everything we talk about because half what we're going to talk about is physics, atoms. The other half we're going to talk about is storytelling, which is what people have done about the stars for hundreds of, maybe as long as people have been talking, they've been telling stories about the stars. And so half this course is going to be looking at the history of what people thought about the stars and why they weren't just superstitious idiots and why they were actually encoding really important information about their civilization and their societies and how to get along and how to work together in those stories. The other half is going to be about atoms. So my background's in atoms, and I have a lot to say about them, particularly because light is all we have in astronomy. And where does light come from? What is light? I'm going to try to answer those questions for you because you won't find them in a PBS documentary, and you won't find them in your chemistry class, and you won't find them in your physics class. So light and atoms are going to be a huge part of our discussion here. Other than that, my day job is essentially running a podcast, which is pretty hilarious. You guys are the online generation, so you probably know all about, who listens to podcasts here? Anybody? Cool. Maybe you'll like mine, maybe you won't, but I run it with my wife. We essentially call up different scientists and philosophers, and we pick on them, and it's really fun. We talk to weirdos, we talk to NASA scientists, we talk to MIT professors, we talk to anybody who has a really interesting theory about nature. So I'll probably link some of those podcasts in the video section of Moodle as we go forward. But you might, one more thing about Moodle, by the way. I should have said this earlier. You're going to be doing these short little video responses every week for your assignments, right? Which is, in some sense, tying in what we do in class. They're like 2-minute videos. I used a service for the last few years for this called Flipgrid. Microsoft deleted it from existence this week. And so I'm struggling to figure out, I think that there's going to be a way to post those in Moodle. I'm meeting with the IT person tomorrow morning. So by tomorrow afternoon, you should be able to post it somewhere. I'll figure out a place for you to do it. I'm really sorry about that. It completely caught me off guard. So anyways, you do have those little assignments, and I don't think I mentioned those, but little 2-minute videos every week that will kind of get you ready for talking on camera and get you ready to do this presentation of your project. Okay, so yeah, that's my podcast. I'm going to be bringing those discussions in, which will make more sense as we go forward. But the entire purpose of this class, and the entire purpose of the podcast, and the entire purpose of everything that I'm giving my time to this for, is because the stories we tell, particularly in science, but the other stories that we tell in mythology, which is that left-handed side of this class, they all are designed to orient us towards a better future than the one that we're sitting in right now. So in its best case scenario, all the theories we come up with in astronomy are going to lead to us living in better harmony with our own planet, planetary science. They're going to lead to us exploring the cosmos in a better way that actually allows us to, find a better future for ourselves because, it might seem a little far off from now, but planets don't last forever, right? So somebody's going to have to figure out a way off of this thing at some point. And it might seem like that's a really far off consideration, but I think if you peel back the layers of what NASA is really doing, what this whole project of space exploration is all about, is trying to find a new home for us to some extent. So that project is surprisingly central to everything that we're going to be talking about here. And all of it, I think, is orienting us towards the future. So that's what I'm all about. I also do a lot of music and a bunch of other things, and I look forward to meeting you guys and chatting about all of that. But let's get into the solar system a little bit. Let's get into astronomy for a second. So, you guys, anybody been to Crater Lake before? Yeah, it's pretty beautiful, right? So this is a view of Crater Lake up here. Now, imagine looking at the sky here, and you have the Milky Way. You guys seen the Milky Way before? Right, which is the galaxy that we're inside of, and we'll talk about that in a minute. Now imagine looking up at that sky and not having any concept of what science is, or what rational means, or anything associated with the modern age. Just imagine just looking up and seeing it. What do you notice about it? Anybody? Every night you watch this thing. What's happening? Yeah. Yeah, and are they like day to day? What do you see?
Kind of rotating, like.
But it's kind of the same, right? Yeah, exactly. So you have some motion, right? The sky is moving above your head. Some of the things in the sky are basically there every single night. So that's, in some sense quite reassuring actually, but some of the things aren't too. Some things change, right? And we'll talk about what those things are that are changing, but throughout the course of a year, the position of, say, this Milky Way is going to change. The position in which the sun rises and sets is going to change. And it's going to do it in a really predictable, ordered fashion. Now, I think this is, I'm speculating here, but I imagine that this idea of studying, so in other words, watching very carefully these changes, was probably the very first kind of science in the sense that I mean it. And what's a science? Well, a science is essentially some system of making explanations for what's happening, right? And to some extent, the technological arm of science, engineering, is being able to forge predictions about what's going to happen next. You might think, like, who cares about predictions? But the reality of the situation is, if you can start to make a pattern out of how these motions change in the sky, you have a great deal of power over your future all of a sudden, actually. Think about one of these people. I think that the latest estimate is that there was people in Oregon something like 20,000 years ago. Think about being one of those people. What are you doing? How are you surviving? Well, you're probably not calling DoorDash. You're probably not rolling down to Safeway. You're probably not going to the mess hall, right? You got to basically hunt or collect plants to eat. I think that most anthropologists, archaeologists don't think that there was widespread agriculture 20,000 years ago. But that appeared at some point, right? So you got to know, those people got to know when to plant, right? And what's critical to all of this is basically setting up a clock, the idea of a clock, a pattern that's repetitive, that happens predictably time and time again. So the sky, I would posit, for most of human history was this giant clock in the sky. And people would study the heck out of that thing. And they would find ways of conveying what was happening in the sky. And again, most anthropologists, most archaeologists would tell you they didn't have written language 20,000 years ago in Oregon. I don't know if that's true or not. Maybe we just don't have records of it. Maybe they did. But let's say they didn't have written language. How do you convey the knowledge from generation to generation about what's going on in the sky, the patterns that are expected? Absolutely. So, and what kind of stories, you know? How do you tell a story that's going to be memorable, right? It's not a simple thing. Does anybody creative writing people out there? Anybody? Yeah, cool. How do you make a memorable story?
You just get really good at being animated.
Animated, right? That's a great. I love that you use the word animated because animus comes from the actually is similar to the one in animals, right? So these like beings essentially that are moving, these life forms, right? So what you find is that a lot of the stories people are telling about the sky back into the ancient world, they actually look up and they see these beings everywhere, right? They see these mythological entities, these dragons and these just entities, right? And you might think, you know, it's a very lowbrow kind of like midwit examination of the matter to just say, oh, they were just superstitious idiots because they're telling stories about these creatures that we know don't exist. And obviously we know the stars are burning balls of hydrogen. They're not, you know, dragons and fish and all this stuff. Well, you know, slow down there for a second because these stories that they're encoding about these animated beings actually contained the seeds of the knowledge that allowed those societies to flourish. And we're going to look at some of them in depth because what's really freaking crazy is that people on different continents were telling very similar stories about the stars in the sky. That's pretty nuts if you think about it. So, you know, actually had a really interesting conversation with this guy that I'm editing right now to put out next week for the podcast. This dude who's what's he call himself? An archaeoastronomer, I guess. He's in Australia, and so they have a really isolated indigenous community in Australia, right? They have these people that have been living out in the middle of Australia where it's just like a desert hellscape, completely cut off from you know, Western civilization for basically tens, maybe 100,000 years. And they tell these rich stories about the skies. And what they're discovering is these people know so much about these stars. They knew about these binary stars that were occurring. They knew about just different changes in the equinoxes and so forth that have occurred over the year, the precession of the equinoxes, we'll talk about that. But what's even crazier is these Australian indigenous people are telling very similar stories about, say, the planet Venus, that the people in Mesoamerica were telling about Venus, that the people in Sumeria were telling about Venus. Their gods in these stories are doing the same actions. So what's up with that? And we'll have plenty of time to unpack that as this course unfolds. And I want to look at those myths specifically because I think they're really, really important. Because what they've done is they've encoded something that's deep inside of ourselves, right? There's something about our lives and the way that we experience the world that plays out for people no matter where you came from. And so, yes, these stories were encoded in oral traditions, and they're handed down and they're cultivated, but they also are reflective of something that emerges from deep within us, no matter where our background, where we come from. And that's really, really profound, actually. You know, there's also an alternative theory. There's always alternative theories. And another alternative theory would be that the reason we tell the same stories is because we all descended from a common ancestor back in Africa at some point. Maybe, right? Might be so, but it makes a lot more sense to me that we're all experiencing very similar things. You live in a dorm with a bunch of people. You have similar conflicts and alliances and decision-making paradigms that somebody else living in a dorm in Japan is having, right? Everybody's, in some sense, having these archetypical experiences with one another. So we'll play with that as we go along. By the way, it was really hard to stay alive 20,000 years ago. You know, up until about 200 years ago, something like 6 out of 10 children survived to adulthood. And so, you know, being able to keep track of where your food sources are, what time of year it is, where the migrations are, what time it is to plant, these things really, really mattered to these people in a way that's difficult for us to understand. So, constellations. You guys heard of these? So in our Western canon, there's 88 of these constellations. Again, what's really, really crazy is that in the East, in the West, in all of these different cultures, people point to the same constellations. Now, they have different names for them, right? So we have, Leo and Gemini, these characters that go along with the myths that we've told all the way back down to the Sumerian tradition. These ones kind of stem from Greece, but Greece borrowed them from the Sumerians. But what's really crazy is that, over in China, for instance, you have very many of the exact same constellations are highlighted. And again, why is that? Why in the world did the Chinese people, the ancient Chinese people, pick out the same clusters of stars and tell stories about them? I mean, to some extent, it's probably because those are I'd love to do this experiment, actually. Maybe we'll have time for it. But this gentleman, if I could remember his name, this archaeoastronomer in Australia, he was saying he did this experiment, and they're publishing this, where they would bring people into an auditorium, and they would have, project an image of the stars on the wall. But they wouldn't be the real stars. They would be like some made-up version of the stars. I think he said what he actually did was zoomed in really far to one portion of the sky and blew it up. And he had people say, pick out the constellations here, and then tell me a story about them, something like that. And what was really remarkable in his study, which I don't think has been published yet, was that people picked the same clusters of stars. So there's something about the way that our brains map this random data into units that we can then start to process as stories. And then remarkably, we end up telling very similar stories because we're all human beings and we're having the same archetypical dramas play out in our lives day to day. So, by the way, archetype, you guys heard this before? What does it mean?
It's like a general understanding of something that can be applied to other things.
Yeah, it's kind of like a role or something. You ever find yourself like in a group of people, you might be like, I'm the joker, or I'm the witty one, or whatever. We each see these patterns of behavior that appear over and over again. And I think that there's something really deep to that about the way that our societies are organized. We fall into these roles and we have these archetypical behaviors. And a lot of what these mythologies are doing is trying to encode that information. This is a Mayan version of the sky. Different, same constellations, different stories. And I want to talk about all those things. But in general, I think what is so important to all these ancient people, and by the way, guys, if you stay in the class, we're going to get into all of these individual stories, and it's going to be really fun. I always love doing this because I learn a lot more each time that I study them. This idea of predictability, I think, is the central organizing feature of a society, ultimately, really. I think that our ability to know what comes next is what makes existence tolerable with other groups of people. So let's think about it for a second. Anybody ever, anybody watch that Netflix show Chimp Nation? You guys ever seen monkeys behaving in the wild before? Anybody? They're freaking brutal with each other, okay? It's really scary and dangerous probably to be a monkey, from what I can tell, particularly a chimp. They're wild, they're very violent, they're very dangerous. And I don't know how to put this to you, but humans are actually, especially men, we can be quite dangerous ourselves as well, right? I mean, obviously murders happen still, unfortunately. You would think we would have grown out of it by now. Robberies, all of these infractions of what we would call social norms happen, right? But they're not the norm. It's not normal, right? You guys can all come into this auditorium today. You're all sitting there, you're pretty chill, right? You're not worried that the guy sitting next to you is going to just stick you with a pencil all of a sudden, right? Why? Because it's a predictable situation. This auditorium is completely predictable. You guys even know which way to sit when you come in, right? Like, I'm up here, I talk, you guys know how this goes. You sit in the chairs. Nobody was just coming up and sitting on the stage, right? Because you have these predictable rules of how you're supposed to behave. And you might think, man, rules are a real drag. Like, they really keep me down and stuff. But it's like, man, rules are the thing that make this entire existence bearable. It's the reason we can all live together in this room and not claw each other's eyes out constantly. We agree to this, right? So for people to be able to look up at the sky and make a set of rules for how that's going to go down, and they seem to work, that's an organizing principle for a society as far as I can tell. Hey, look, the stars behave regularly. We could do that too. You had a question?
Would you say that there's a difference between like rules and order?
I mean, order is what I'm driving at here. So order might be the way that we talk about nature, right? And especially if we looked up at the sky and we start assigning these animated characters to what we see. We're ordering the sky. We're chopping it up into sections. We call them constellations, right? But ordering of things is the fundamental human's pro-social attribute. This is like, we can't exist without ordering things. And so, the funny thing about science that we're going to find, and what is a theory? It's just taking a bunch of data and ordering it in a way that makes sense, right? It's this cause and effect story. A story is a form of putting order onto chaos, by which we're able to handle it all of a sudden. Maybe we can even make predictions off of it. That would be really nice. We know when to plant our crops, or we know which way to shoot our rocket so that it reaches the moon that we're aiming for, right? This is fundamental to the project of science, and I think that the storytelling is fundamental to the project of constructing a society. And constructing a society is this really crazy job that we've all inherited. I don't know if you guys think about it too much, but we're all involved in it, right? I mean, of course you can vote for like which party or whatever you think is cool, but everything that you do is ordering the society. Every rule that you support and abide by every time you come in and sit down in the chair properly, you're essentially continuing a project that was set out by, go back to the first people, right? And it changes across time, right? The world changes, the roles that we have to occupy change, but we're ordering them constantly, and we're setting up the next generation of people. It's this, quasi-eternal, if we're lucky, it's essentially an eternal process of ordering the world that we live in. And so science is a really funny version of that, because people go absolutely nuts defending their versions of order, right? I've never seen people be so completely vicious with each other, like more vicious than an MMA fight with each other at scientific conferences over which way nature works with, right? I've seen people throw hot coffee in each other's faces over theories. I'm not kidding you. Like, why is that so important? Why in the world would you come to like fisticuffs with somebody over a scientific theory? Because that's how important it is that the world has order to it, to people. Like, we don't think about it in our heads like that, but deep in our hearts, we realize that we need some sort of unified story for these things, because otherwise people don't know how to orient themselves to the world, to the future, to one another. And it might seem completely trivial that we tell these stories about the sky, and that who cares, they don't really affect things on Earth, but they reflect the way that we approach ordering the rest of the universe. And I think that's why, and the rest of our daily lives and our societies, and I think that's why people are just so absolutely vicious with one another over these theories. So we're going to see conflicting theories a lot as we go through this course. All right. This is let's see if I wrote this down. This is from the Near East. I don't have do I have a date for this? Yes. All right. This is the Aurignacian culture. I think this is from, do you have a date for this? Yes, 30,000 BC. So this is a bone carving from 30,000 BC. So that's more than 30,000 years ago, 32,000 years ago approximately. And people were already listing, by the way, the correct positions of the stars in Orion. They also had it associated with this hunter guy 30,000 years ago. I can't even imagine. Think about how much life has changed in this country in 100 years. How about since I was a kid, right? It's a completely different country from when I was a kid. Think about how much the world changes in 30,000 years, and yet people are still have this story of Orion, the hunter, which people are telling now, or at least, in the Greek times, which is only 2,000 years ago. They basically are telling some version of the same story. By the way, we'll see this again. So in these Lascaux cave carvings, these are very famous cave paintings, sorry, not carvings. Same thing. We have Orion over here, which is depicted as some sort of a hunter. And there's a bull. And the bull and the hunter appear in all these different societies all around the world. So initially when this was discovered, first of all, when it was first discovered, people were like, oh, that's a cute cave painting by these primitive people and everything, sort of pat them on the head and move along. Some hundreds of years later, I think 100 years later, an astronomer went and visited the cave, and he said, wait a second, these little dots that are everywhere, I think they're actually important. And he realized that, we have the Pleiades, which is a very obvious, it's not a constellation, it's an asterism, which is basically a baby constellation. But it's very obvious. If I took you out in the night sky, you could see the Pleiades almost all the time. Orion and Taurus are also always visible. Now, so this guy, I forget what his name was, he published this paper and he said, hey, I think they're actually making star maps here. And people were like, no, they can't really be because the stars, the positioning is all wrong for them. Well, turns out that the stars move. And over 30,000 years, they actually move a fair amount. And they reconstructed it using a very similar simulator to the one you guys are going to use in the workshop portion of this class. This is really cool. If you go into that workshop and you just want to get lost sometime, go way back in time and see how things are different. It's really cool. You can go back to your birthday and see all the stars that were there. The guys nailed it. That's exactly where the positions of the stars were 30,000 years ago. So they were exacting. They weren't just some, I think that there's a hunter-looking thing in the sky. I'm just going to draw it. No. These were exacting measurements of where the positions of those stars were 30,000 years ago, okay? So people really cared. They really cared about the precision of these placements because, again, ordering the world is fundamental to being a human being. Your whole life is, a huge problem for all of us, I'll count myself amongst you, is anxiety, right? I mean, who doesn't have anxiety sometimes, right? But what is anxiety, if not a sense of chaos, a sense of not having a clear picture of how some ordered process is going to unfold? You have anxiety maybe about final exams, right? Well, because you don't know how you're going to do. You haven't seen the test yet. You don't know how it's going to go, right? So it's complete chaos to you ahead of time. Then you go and, you slay the dragon and you come out and you got an A on the test and you feel good about yourself. But the fundamental process that we're doing in all of these situations is trying to order all of that chaos, because without it, we're basically chimps tearing each other's heads off. And that's really scary. So I think even the stories, the fact that these predators appear over and over again in these stories is really important because people are living. Have you guys, anybody do like outdoor stuff, camping, hunting, stuff like that? I mean, the beasts out there are pretty wild. I came face to face with a cougar one time, and it was a wild experience, right? It was dark. It wanted my dinner. It was maybe we were camped at the edge of this canyon. It was right down in the gully. I could just see its eyes glowing back at me, and it was just made this crazy noise. I think that people understood that there's predatory animals out there, and in order to live with those animals, they ended up coming up with stories about the motivations of those creatures. Because if you can understand a predator, right? Why is true crime such it's off the charts as far, you guys watch podcasts. I guarantee a few of you listen to true crime podcasts. Yeah, hands? Anybody? Couple? Yeah, because when you understand the mind of a predator like that, then you can understand maybe how to avoid that situation, or you can understand how to maybe live with that predatory element, right? So a lot of the things that we're going to be telling stories about involve these predatory, dangerous situations. A lot of it is geared, once again, towards ordering your environment in such a way that you can put handles on it, move things around, and deal with them, ultimately, right? Like when I saw that cougar when I was, rock climbing in the canyon a few years back, I had a story in my head for what a cougar was. I already knew that because somebody told it to me or whatever. So I knew what to do when the cougar wanted my dinner, right? I grabbed a big stick from the fire and I like chased the cougar off, right, and screamed at it really loud. But if I didn't know what a cougar was, no one had ever told me, and there's just some crazy monster staring at me screaming, I'd probably just give him my dinner and run away, right? So there's ways to handle things that are dangerous, and those ways are encoded in the stories we tell. Today, perhaps the closest thing we have to mythology is like pop music, Netflix. I don't know if like the short form media constitutes this, but we still tell these archetypical stories. I think they're making, how many, they're on like Batman 57 or like, right? It's like how many times are they going to remake these Marvel movies? Why do they keep doing that? Because they can't beat those stories there's a stuck culture argument to be made too, but like ultimately these stories appear over and over again because they're important to us. They really do help us orient to the future. All right. So as we go through this course, I found this really cool book. Actually, my dad gave it to me for my birthday a long time ago. It's called Native Science, and it's by this gentleman named Gregory Kahete. Highly recommend it. You can find it on Amazon or wherever you guys get books. But I'm going to read some little pieces from it because it offers some firsthand perspective on how people traditionally, through these oral traditions, have seen the stars in the sky. And so far, this lecture has leaned heavily on the mythology. We're going to get definitely into the nitty-gritties of the atoms and all of that business as we go along too. But I'm going to try to balance it as I go, and I want to read some little portions from this as we go ahead. And so this is from the Navajo tradition, and I couldn't find one for Oregon, although there probably is one, and if anyone knows it, go ahead and tell me after class. What these people are trying to do is make meaning of the sky. So I just want to read this to you so you can hear it in their own words, and then maybe we can talk about how that compares and contrasts to what's going on here with ordering things. So he writes, this is trying to make sense of the sun and the moon. First man and first woman brought the energy of the sun, moon, and a crystal star from the first world. In the second world, Coyote, first boy, and first girl were created. And together they brought the knowledge of heat and light from the clear crystal to the fourth world. This is our world. All of which was eventually used to produce the sun. The holy ones decided that the sun, considered to have male characteristics, would provide order to the days and seasons. The seasons are recognized by the location of the sunrise. Referred to as the day traveler, the sun is used to determine time in a general sense as well as to determine the cardinal directions. The equinoxes and solstices are considered sacred times of the year, the end of the sun's journey marking the passage of time in the seasons. Blessing away ceremonies are held to ensure that the actions of the people on the earth are in harmony. At these times, it is said that for thousands of years, the sun, moon, planets, air, water, and electrical forces have aligned themselves at these times, a universal alignment where energy is shared. The moon, referred to as the night traveler, was created to provide another source of light at night and to provide another measuring tool. The Navajo recognized that the moon has shorter cycles compared to the sun. Because of the 28 to 30-day range of the moon phases, the moon provides 13 months. Nature and human activities on the earth were used to name the months. Because of its gentle character and direct correlation with women's menstrual cycles, the moon is considered female. All right. So there's a story, right? Now, I don't think there's any astrophysicists alive who's going to tell you that the moon is feminine and the sun is a masculine entity. You're not going to hear that from Neil deGrasse Tyson, right? But it's an important story nonetheless, right? Because being male and being female are two wildly different experiences, right? For many, many years, people seem to have really struggled to align the moon with the sun in terms of timekeeping as they've gone along. So you guys have probably seen this one, Stonehenge, right? Did a great job of marking where the solstices are, so the longest days of the year. But it's unclear if they were how they were able to fit the moon into that. Now, there's another, we'll get back to that. There was another site, this is from Scotland, where people were trying repeatedly to align the phases of the moon with the actual solar calendar, right? And you might think, well, that's basically impossible task to do because you have 13 of them. They're not exactly 13. And you have the sun, right? You can't actually fit the number of moons into a year. And so people tried over and over again, and they beat their heads against the wall. Why do you think that they tried to do that so badly, right? What do you think that why would you want to fit the moon into the sun so badly? 30 days, 365 days for a year. They don't divide evenly. It's really hard to count days of the year. You need 365 of them, right? With a month, you can actually see the phases of the moon changing, right? The moon goes from a crescent to full, disappears eventually. It's very predictable. So there's a clock there. And if you could make those two clocks fit together, then you would have a really good idea of how many moons had passed and therefore what time of year it is without even having to look at the sun. That would have been really nice. This point that they make about the menstrual cycle is actually really fascinating too. So this is hotly debated in the scientific community. There was actually a Nature paper that came out in the 70s that made the claim that if you take women and you isolate them together, that their menstrual cycles will lock up. And coincidentally, the menstrual cycle is almost exactly the same length on average as the phases of the moon, which really makes you wonder if this system of fertility didn't evolve alongside the moon. Because think about it. I don't know if you guys... Okay, so most primates, when the females are in heat, right, when they're ovulating, let's say they're fertile, they're receptive to becoming pregnant, their bodies change wildly. The colors of their faces change, the colors of their genitals, they change very, very much in almost every other primate. Humans, not so much. You can't really tell, actually, when somebody is fertile, right? So the theory goes that perhaps humans' menstrual cycles, the fertility cycle, is aligned with the moon so that different groups in their tribes could actually tell when the women were receptive to fertility. It could just be a complete coincidence that they're almost exactly the same length of time, of course, but it's an interesting theory. Thoughts? Everybody's deeply uncomfortable with fertility. We don't talk about that here. Okay. Think about it, though. It's pretty crazy. One of the tricks that people came up with very quickly, let's see, this is, I think, from about 16,000 years ago. In Germany, this is called the Nebra disk. So they're trying to work out how do we fit these moons into a year. And they came up with this idea of a leap year pretty early on. So they're like, look, we have, mostly we're going to be able to fit 13 of these moons into a year. Every once in a while, we're going to subtract one, or we're going to add one, and we'll catch up on our solar calendar that way. And so this, I can't actually decode this disk for you, but the authors of the study claim that this disk encoded information about how to add that leap year and how to take it away. You guys got a question? Okay. All right, so starting, written language is kind of obviously where our archaeological story can actually get its teeth in, because before written language, we're talking about oral tradition. Now, like I said, Aboriginal people in Australia still cruising along with oral tradition. By the way, very difficult to access, because every time that they talk to some Westerner about their esoteric oral knowledge, they open themselves up to exploitation. And these people are really, really concerned with that, and they don't want to give their secrets away, justifiably so. I don't know if you guys realize this, but there was indigenous people in Europe before the Romans killed most of them, mainly called the Celts. And they actually had a priest class of people, just like the Sumerians we're about to talk about. Their job was just to keep all of that knowledge about the universe and to transmit it in stories from one generation to the next. Well, unfortunately, that made a really easy situation for the Romans who were looking to destroy that culture, because all you got to do is kill off the priests, and there goes the entire cultural knowledge, right? So we have almost no information. That's why people talk about the Druids like it's some mystery cult or something. Look, the Druids weren't a mystery. We just killed all, well, we, in so much as we're an inheritance of the Roman civilization, The Romans killed, particularly Julius Caesar, killed them all, right? Literally killed all of them, all of the priests. And that was the end of that lineage of knowledge. So oral history is really vulnerable to being cut off at the knees. So the Sumerians, as far as I can tell, are one of the first instances where we in the West, so let's say English-speaking people, can actually reconstruct what these people were thinking about the stars. And so these are some of the first star maps that we have that we can actually read stories alongside of them. Now, there are also star maps in ancient China that are contemporaneous with this. There are ancient stories in India, but there's geopolitical problems with us accessing those. So China, huge language barrier. I have tried to get to the bottom of Chinese mythology regarding the stars. It is basically impenetrable. So if you don't read Chinese, the Chinese internet is all in Chinese. It's very difficult to access that knowledge, that whole wing of knowledge. India is a similar situation because what happened in India? Well, India was under colonial rule by the British at the time that archaeology became a real, institutional science. And the British rolled into India and they started telling all these stories about how the ancient Indians were essentially descendants of their people. And so when the Indians finally kicked out the British, they basically rejected all of the stories that the British people had laid over top of their ancient people. And so now there's this invisible wall in Indian archaeology where the Indians have a very different story than the Westerners about what happened there, and people can't make heads or tails of it, and there's not much of a crosstalk discussion. So there's all these geopolitical forces that are getting in our way. For that reason, I'm forced to start this anthology with the Sumerians. And we'll talk about the Sumerians in depth in this course if you hang around. But does anybody know where the Sumerians lived at? Sumer, where was it? Yeah, like Baghdad, like the cratered, bombed out place, right? That has been all but wiped off the face of the earth. Which is really tragic because it's like the birthplace of Western civilization and it's been bombed into ruins and completely destroyed. But yeah, these people, and you can imagine Sumeria 5,000 years ago. It wasn't Iraq as we know it. It wasn't this desert wasteland back then. It's actually a really fertile place. So you had the melting of the big glaciers at the poles, right? About 12, 13,000 years ago, something like that. And during that time, there was tons of water coming in, right? The sea levels were rising, all these glaciers were melting, huge rivers flowing everywhere. It was a really nice place. And so this was where we start to see the birth of agriculture. Maybe a little bit earlier, they've started to find all of these proto-civilizations a bit north of there in Turkey. So I don't know, have you guys heard of Göbekli Tepe? Göbekli Tepe, yeah? A little bit hot topic if you're in the podcast world. There's a lot of people struggling to understand what those people are about. Their culture resembles in many ways the Sumerian culture that proceeded from it a few thousand years later. What's really weird is there's about 3,000 years of missing history between the people at Göbekli Tepe and the people down in Sumeria. So we don't know what's going on in that period. But at any rate, Sumeria pops up. Now, Sumeria is really, really weird, too, because Sumeria, the language that was spoken there, had no precedent. In other words, if I try to reconstruct the language I'm speaking right now, I can basically go back through time and say, okay, we took this word from German, this word from Latin, this word from Greek, right? I can reconstruct almost every word that I'm speaking to you right now. You can't do that with Sumerian. It seems to have just popped out of nowhere, which is really, really, really weird. It doesn't come, obviously, from any Indus roots or any European common language from Greece. It doesn't come from anywhere. It's really, really weird. So all we know is the civilization springs out of nowhere, essentially, after the last, quite a bit after the last Ice Age. Maybe some aesthetic parallels to that Göbekli Tepe civilization. But they start writing everything down on these clay tablets, which is really useful for us. So they make this very articulate grid for the sky. And, why am I telling you all this? Well, has anybody ever thought about how bloody strange it is that our clock is divided by sixes? Like, we do everything else by tens, right? If I count, I do count in units of 10, right? I just add a 0 and I've got another unit before it, right? Like basic arithmetic. Everything in our civilization is done in base 10, except for that, which is pretty weird. You know what else isn't done in base 10? The way that we talk about the position of the stars. It's all in base 60. Where did we get that? Well, the Sumerians did everything. All of their math was in base 60. We're still using the Sumerian system for our clocks on the wall. This is nuts, actually. Actually, it's really, really strange that we keep doing it because it's not particularly convenient to translate between units of time. Right? If you've ever taken a physics class and you got to go between time and anything else, the units are all messed up. You got to do these fantastical unit conversions. So when we start talking, and we're going to be talking about this very soon, about the way that we measure stars in the sky, the way that we find different constellations, and the way that we find stars, and how we gauge our distance to them, we do it using the Sumerian system, which is the sexagesimal system. It's base 6. So why base 6? Or 60, sorry, 60. Why? Why in the world? Anybody? It is evenly divisible, that's for sure. That's right. But like, why?
I immediately thought, I think this was kind of after the fact that the circle was 360 degrees, but I think it could be related to that because of the rotation of the Earth, like around with the sun positioning.
I mean, I think that the fact that the circle can be cut up in this way is really important. But I guess you could have taken the circle and divided it into tens too, right? I don't know the answer to that. You got an idea? Yeah.
I was going to say, like, we have 12 months, which is divisible by 6 as well. And all the weeks and stuff.
That's interesting, the moon relationship. I hadn't thought of that. So there's technically almost 13 moons in a year, not 12. But that's an interesting point. I've heard also that if you take your 3 fingers, you can count like the digits on it. 1, 2, 3, 4, 5, 6. You can do this. That doesn't really sit well with me. I'm completely open to ideas, so think about it. I'll check at the beginning of next class if you guys have any ideas. What's important is that these guys, thousands of years ago, set up a system that has basically no relationship to the rest of the way that we do the rest of arithmetic and mathematics, and we still use it. So I think it makes Sumeria a good reference point for us as we go ahead. But it's pretty bizarre if you think about it. And there's all these things in our world that we inherit, these sets of order that we don't really think too much about. Yeah, there's 60 minutes in an hour. It's like, yeah, you just learn that when you're a kid and just roll with it. But it's like, why in the world do we do that? It makes no sense, right? We don't divide dollars up into 60 cents. Okay, there's something else worth mentioning about these Sumerians. So just like the Celts had the Druid class that was preserving their knowledge, the Sumerians also had a class of people called the Chaldeans that did all of their record keeping for the stars. Now, they wrote it down, which is why we actually can look at it. We can't look at the Druids' system, which might have been really interesting. Unfortunately, no one will ever know. The Chaldeans are interesting, though, because they have their own part of Sumeria. They live in one little portion of town. They're not particularly well regarded, so they don't have a lot of wealth or power in the traditional sense. In fact, they're like a quasi-slave class in Sumeria, it seems like, which is really, really weird until you start thinking about who keeps all of our knowledge today about the stars. It's not a trick question. It's basically professors at universities, right? Also not really well paid, by the way, professors in general. And I think this kind of gets back to answering my question about why these scientists are throwing coffee in their face at the end of the day. When you're a scientist, you come up with a theory. Let's say it's the most remarkable theory that's come along in a very long time. We could say the theory of DNA as a hereditary molecule, or evolution, or a popular one for the last 100 years has been general relativity to explain the motion of bodies with respect to one another. What do you get out of coming up with a theory? Do you get money? No, you don't get money. If you win a Nobel Prize, which you probably won't, there is some small purse associated with it, but it's basically just a token. all that we really give to the people that hold our knowledge is prestige in society, right? If you come up with this theory, you're important. People respect you, right? That's it. That's all that scientists have is their credibility and their respect of the world and of their peers. And I wonder if it wasn't something very similar with the Chaldeans back then. So clearly they had a lot of power because the kings in Sumeria would call them in and say, what's the sky going to do next Thursday? And they were able to actually tell this because they'd been watching it and making charts, and they could actually tell these stories. Now the king would then often take that knowledge and he would use it almost like because the rulers in Sumeria were essentially these god kings, right? The people believed that they were the embodiment of their highest supreme being. And in some sense, the way that those rulers would be able to claim that authority is because they could actually make predictions that came true. They knew when the sun was going to be blotted out by an eclipse ahead of time, right? How'd they know that? They knew that because they had these guys behind the scenes, right? They're academic nerdlings, right? That were hidden away, who were able to calculate all of this stuff for them and give them that knowledge that they could actually use to then make claims on the future, which I think probably gave them a real sense of authority in many different situations. So things maybe haven't changed too much in that regard. By the way, we talked a little bit about this, but why do you think people came up with this idea of having kings in general? I mean, we usually think of kings today as tyrants. We wouldn't want kings in America. Yeah.
It's like you said earlier about the desire for order. When you have that baseline of like something people can rely on, and they can start building out and forming better civilizations.
Yeah, it is definitely about order. Can you elaborate on what exact type of order, though? What does a king do to a society? What particular order do they give to it?
It's like a figurehead. Consistency represents that there is an organization that people fall under.
Like that they're subordinate to, right? So, they have this really big problem in tribal societies even today. This was something that, when the United States tried to go and occupy Afghanistan for the previous 20 years, and it was a complete disaster, they didn't understand how tribal societies work. And there's a real problem, actually, with societies that don't have these far-reaching, subsuming hierarchies. And the problem is, let's say I'm living on a plot of land. With that, we don't have a king structure, right? We have a loose affiliation. Maybe we have some ethnic and religious traditions that bind us, shared mythology. Okay, cool. We have the start of we have a language that we share. Great. What happens if, one day your dog gets loose and it eats one of my goats? Well, I'm pissed. My goat got eaten, right? So what am I going to do about it? Well, I could go and kill one of your goats, right? Well, what's going to happen if I go and kill one of your goats? Well, you might come and kill two of my goats. And next thing you know, we've killed all of each other's goats, right? Maybe it's worse. Maybe you come and kill one of my family members, and then I go and kill two of your family members, right? So kind of the invention of this social hierarchy in the sense that you put an authority figure, and by the way, in the Sumerians, they believed it was a deity, right? Supreme authority. What you do is you actually set up a situation where the buck stops here. When the king decides, right? And some of the tribal systems have also replicated this where you have a chief. And when you come to the chief, all right, so your dog eats my goat. Instead of me going and killing your goat, now I go to the chief or I go to the king and I say, hey, this guy's dog ate my goat. The king can adjudicate that situation. He can say, all right, you owe him like 30 loaves of bread or something like that. And that's it. That's the end of the dispute. It's not going to go on for multiple generations where your kids are killing my kids over this goat that got eaten 50 years ago. And I think that kind of phenomenon tends to happen in situations where you don't have an actual authoritative structure at the top of it. So anyways, the Sumerians invented this, and lots of people invented this king-like structure. And I think it wasn't stupid. I think it was quite useful. And by the way, today, the fact that we have courts is a real... Anybody ever found themselves in the judicial system? It's a bit of a nightmare, right? I have too. My YouTube channel has been sued before It was a complete nightmare, had to go all the way through the Supreme Court. Very expensive and time-consuming, but it works, right? At the end of the day, you know, someone has a grievance with you, you settle it according to rules, you play it out, and that's it. It's over. They don't get to come back and do it again. They don't get to sue you for the same thing twice. You can't do that. If someone accuses you of murder, right? Well, they can't do it twice, right? You go through the system and it's done. It's over. And so there's a finality to this that seems to be really, really important in creating that order. So the Sumerians set up this whole system. There's a king, there's a bureaucracy, they have these people studying the sky that are giving information to the king who's using it to make predictions, using it to divine different ceremonies throughout the year. And the king ultimately exists to settle disputes, as far as I can tell. So this is a really wild innovation that occurs at this point in time. It also, by the way, it occurred in ancient China, occurred in ancient India. I don't have as much access to that information as I would like to. But it seems to be something that humans invent over and over again. So the king concludes disputes. The bureaucracy exists to actualize the reality once that dispute's been concluded. Okay, so we got 10 minutes left. Whatever I don't make it through this time, we'll pick up there next time. What's up with this word astronomy? Astronomos in Greek. Anybody know what astro means? Stars. Yep. What about nomos? I'm going to keep doing a lot of etymology with you guys because I think it's really fun. We make these sounds with our mouths, and we have no idea where they come from a lot of times. Nomos means law, actually. So in that sense, astronomos, laws of the stars, right? It makes a lot of sense that it popped into existence in Sumeria with the birth of law in general, right? Because the king actualized the law, sets up these rules. The bureaucrats encode those into laws. Once the king makes a ruling that, hey, if your dog eats my goat, I owe you, you owe me 30 loaves of bread. That goes down as a law, right? That orders the civilization in such a way that you can rest assured that if this ever happens to anyone ever again, that's what's going to be the result of it. And so if you're the guy who's got the dog, you want to make, really darn good sure that you don't let your dog off its leash because you can't afford to be giving away 30 loaves of bread, right? In a world where half of your children are not even going to make it to adulthood, you need to make sure that you have your loaves of bread. So laws, these are essentially laws of the sky. That's where we get that word. Now, laws are interesting, but they're not science. And so this is where we start to pick on that word science a little bit. Because particularly in physics and particularly in the physical sciences, I think that there's been a terrible, terrible confusion about the difference between laws and explanations. So I'll give you a quick example. We have Newton. Does anyone know? You guys know who Newton was? He's the gravity guy. Exactly. So Newton, and we're going to tell this whole story, by the way, in all the luxury of detail it deserves, because it's kind of a cool story. Newton essentially comes up, and he's working on the backs of all these people before him, and we'll talk about that. He comes up with this nice equation, a relationship, a law of quantities that scales the attractive force between any two bodies based on this concept called mass, which essentially tells you how many and what kind of atoms there are in that body. Now, a lot of people would probably tell you that Newton, that this was a great achievement of science, that Newton did this. Well, in some sense, yeah, he picked out a pattern, he ascribed variables to it such that it was predictable. You could use this relationship at different parts of the sky with different bodies. You could use it here on Earth, for that matter. But what Newton didn't do, and he wrote actually an appendix to, so Newton's magnus opus is called the Principia. I don't know if I'm saying that right, it's Latin. But he wrote this book, and then a few years later, he wrote a little appendix for it. And he said, hey, by the way, I know you guys are in love with what I've done here, but I didn't actually explain gravity. All I did was describe how gravity occurs using these variables here. And he said, I'm really sorry about that. I have no idea what is holding these different bodies to each other. He then goes on to say, furthermore, it is not the job of the natural philosopher to explain cause. That's something that we'll get to later. We'll get to that one day. We'll figure it out. But today, we're just satisfied with writing these laws, these relationships amongst, the different physical actors. Now, in my opinion, that's had a tragic downstream consequence of the fact that we never really got around to it. So many, many years later, we'll talk about all this later, Einstein came along, and a bunch of other people, and they redid those laws so that they were a little bit more precise. This is the theory of general relativity. But guess what? General relativity is also a relational expression that describes how those bodies work with respect to each other. It doesn't explain anything, actually. And so there's an element of science that is beyond just the laws, where you actually have to look at the laws and then formulate a cause of those effects. Particularly in physics, of all the sciences, this one is left to the wayside way too often. And so one of the things we're going to keep picking on as we go through this is how much of science is left unfulfilled, because oftentimes all we have are the laws. We have the patterns that we see, but we don't know what causes those patterns to occur. Now, I'll give you a really good example of a system where that does work. So in science, let's say if we look at biology, this is the last thing I'm going to tell you guys today, and I'll let you go. Heredity. How are your attributes inherited? Well, today we know that you have this thing called DNA, right? And it's a molecule that encodes all this information, right? Well, that's a pretty recent understanding, and it's actually a genuine explanation. It tells you how the physical actors combine in such a way to produce the phenomenon, which is your appearance and everything about your physical body. But you can imagine a totally different universe where instead of having an explanation like that, where we have this molecule that does this thing, you just had this mathematical relationship that described heredity. If this person has this particular equation set, let's call it a field equation for their genetics. They have a genetic field equation that lives in the heart of their cells, right? And that equation is modified over time. You can see how eventually, yes, you would have a lot of predictive power still, but you wouldn't have an entire explanation. And so the cool thing about astronomy, astrophysics, cosmology, is that we have a lot of those equations. We got a lot of laws. We have a lot of descriptions of how things work. And we have very, very few explanations. And so cool part of this class is we're going to explore what some people are proposing as actual explanations. And people are still duking it out in the streets over that stuff. So I want to put a pin in it. I hope that I see you guys again next Tuesday. If not, have fun. Take care. And I will, by the way, I'll get the video thing settled by tomorrow early in the day. And you guys can, the first video is just an introduction. So, yep. See you guys.